Okay, let us now have a look at question 1.2. In the diagram below, AC is a diameter of the circle with center O. AC and chord BD intersect at E. AB, BC, and AD are also chords of the circle. OD is joined. AE is perpendicular to BD. Alright, remember with question 1.1 we said before you even go to answering your question, you need to analyze the statement that you are given together with the diagram, and identify the theorem statements, as many of them as you can. We are told that AE is perpendicular to BD, then we know angle E1 will be 90 degrees, angle E2 will be 90 degrees, angle E3 will be 90 degrees, as well as angle AEB will be 90 degrees. O is the center of the circle, therefore it means what? AC is a diameter, therefore we know that angle ABC will be 90 degrees. A diameter subtends an angle of 90 degrees at the circumference of the circle. Angles in the semicircle, and angle at the center is twice angle at the circumference. We know that angle DOC will be twice angle B1, and also DOC will be twice angle A1. Angle at the center, both DOC and angle A1 are subtended by the same arc DC, and also the same arc DC subtends angle B1. Then we are also having what? Angles in the same segment. Angle A1 is equals to angle B1. Angles that are subtended by the same arc, which is arc DC. Then we also have what? Angles in the same segment again, where we are having what? Angle D2. Not D2, but D1. Angle D1 is equals to angle C. These are angles in the same segment. They are both subtended by arc AB. Arc AB subtends C at the circumference of the circle, and also subtends D1 at the circumference of the circle. Alright, then we are having what? Triangles. Triangles, maybe if we look at, for an example, triangle DEO. Triangle DEO. With triangle DEO, we can say what? Angle DOC will be equals to angle D2 plus angle E2, exterior angle of a what? Of a triangle. So we're having quite a number of exterior angle of a triangle. Okay, so now let us look at our questions. If C is equals to 33 degrees, calculate with reasons the size of angle A1. There is A1, angle A1. We want angle A1. C is equals to 33 degrees. But we know that angle A1 is equals to angle B1. Remember, we have identified that angles in the same segment, and we also know that angle E3 is equals to what? 90 degrees. Therefore, if we are in triangle BCE, we can use sum of angles of a triangle to find B1. If we know B1, then we know what? A1. So let us do that. Firstly, we find what? Angle B1. But we start first by saying angle E3. Angle E3. Angle E3 is equals to 90 degrees. And the reason for that, we were told that AE is perpendicular to BD. That is the reason. AE is perpendicular to BD. And then from there, we can now say intra-angle BCE. Intra-angle BCE we are saying angle C. We have angle C, angle B1, and angle E3. Angle C plus B1 plus E3 is equals to 180 degrees. And the reason for that is sum of angles in triangle. Then we substitute. Angle C is 33 degrees plus angle B1 plus angle E3 is 90 degrees. This is equals to 180 degrees. And then let's solve for B1. We get that B1 is equals to 57 degrees. So 90 degrees, this one given. And now our angle B1 is now at 57 degrees. But we have already identified when we're doing the analysis that angle A1 is equals to angle B1. And the reason is that these are angles in same seg. Angles in same segment. Therefore, this means what? This means the size of angle A1 will also be equals to 57 degrees. Now, 1.2.2, we must now find the size of angle D2. Let's look at D2. D2, here is our angle D2. Then we need to check, okay, how can we find D2? How can we find D2? What do we know? We know this is 90 degrees. Angle E2 will also be what? 90 degrees. Ne? E3 plus E2 is equals to 180 degrees angles on a straight line. But now, but it's also possible for us to find angle what? DOC. By using what? Angle at the center twice angle at the circumference. Angle DOC is twice angle B1. And then from there, once we know that, once we know the size of angle DOC, then we can say DOC will be equals to angle D2 plus angle E2, exterior angle of a triangle. Then in that way, we'll be able to what? To find, we'll be able to find what? The size of angle what? D2. So let us do that. Let us do that. Let us do that. Okay, firstly we are saying what? Firstly we are saying we need to find angle E2 and angle DOC. Okay, number one, we can say angle E2 plus angle E3 is equals to 180 degrees. Reason for that, these are angles on a straight line. Then angle E2 plus 90 degrees is equals to 180 degrees. Angle E2 is equals to 90 degrees. Remember guys, it is very, very important to show all the steps that you have used in getting your what? Your answers. It is very, very important. This is going to assist you in a way that even if it happens that along the way you make a mistake and you can see that you have made a mistake, then it will be very easy for you to what? To track back or trace back all your steps to find where exactly did you make a mistake. But if you keep on skipping steps, if you make a mistake, you identify the mistake, sometimes it becomes very difficult to pick up as to where did you make a mistake. Hence I prefer to what? To show all the necessary steps. All right, E2 is now what, 90 degrees. Then we say also what, angle DOC, angle DOC, angle DOC will be twice angle B1. And remember, B1 is what, 57 degrees. So we are saying angle DOC will be equals to twice angle B1. And the reason for that is that there's an angle at center is equals to 2 times angle at circumference. Therefore, DOC will be equals to 2 times 57 degrees, which will be equals to 114 degrees, the size of angle DOC. And then from there, now that we know that DOC is 114 degrees, then we can say what angle DOC will be equals to angle D2 plus angle E2, exterior angle of a triangle. Okay, then we say angle angle DOC will be equals to angle D2 plus angle E2, and then we say this is what exterior angle of triangle. The size of angle DOC 114 degrees is equals to D2, that's what we are calculating, and angle E2 will be 90 degrees. Therefore, angle D2 will be equals to 114 minus 90 gives us 24 degrees. Therefore, the size of D2, is 24 degrees. Let's also put 57 degrees here. A1, we have already calculated what A1. All right. Now the last question on 1.2. Show that AE bisects DAB. Let's go to our diagram. Here is AE. Here is AE. Line AE. Here is line AE. Show that AE bisects which angle? Angle DAB. Bisects DAB. Therefore, what do you need to show? You need to show that angle A1 is equals to angle A2. To bisect is to what? Is to cut in exactly 2 equal parts. Therefore, when we bisect an angle, therefore it means what? Angle A1 in this case must be equals to angle A2. Therefore, what does it mean? It means you need to show that angle A2 is equals to what? Angle A2 will be equals to 57 degrees because A1 is equals to 57 degrees. So 1.2.3 1.2.3 I'm going to do it here. So now let us have a look at triangle ABC. Triangle ABC, you see that in triangle ABC, line AC is our what? It's our diameter. And we know that a diameter subtends an angle of what? Of 90 degrees. Therefore, this means what? This means this angle is equals to 90 degrees. Angle ABC is 90 degrees. We can start there and say angle ABC will be equals to 90 degrees. And the reason we are taking this route is because we already have 33 degrees for angle C then it will be easy for us to find what angle 2 using what sum of angles so in a triangle. Okay, and then the reason for ABC being equal to 90 degrees, these are angles in semicircle. Then we are saying angle A2 plus angle ABC plus angle C will be equals to 180 degrees. Statement reason, and the reason is these are sum of angles in triangle. Then angle A2 plus 90 degrees plus 33 degrees is equals to 180 degrees. Then angle A2 will be equals to what? 57 degrees. Therefore, we can say angle A1 is equals to angle A2. Therefore, indeed, AE bisects angle DAB. Okay, that's it with question 1.1.